right, so that is that. Now let's continue. So today we are going to build on the knowledge we have that the component that we touched on, they are very very important. We need to know that these ones exist. And then now when we are ready to write instructions to interact with these components, we will better know how to go about them. The more reason why we did establish that basis yesterday. So today we are going to start off, to build on the knowledge we have, to look at um, a topic called thinking programmatically. So I'm going to share a slide with you. So what do I want to present? I want to select a window. Can share my entire screen now. So I want to swap this thing. Swap it. No. Can you see my screen anyway?
No, please.
Okay. So just give me a bit of time. Let me share my screen with you. Swap this. So I want to share. To avoid an infinity mode, don't show an entire screen.
Oh, ele me so mfa wa ifa na nya advice. Where for?
Okay. Oh, Daniel Opon. Hmm. Option trader. So let me move. So I believe you can see my screen now.
Please, yes.
Nah.
Yes, I can see your screen. Introduction to thinking programmatically.
Yes. So that is what we are geared to look at this evening. Introduction to thinking
I can see it
programmatically.
now.
Now, in our quest to learn how to write instructions for the computer to understand, we need to also prepare our thinking ability in such a way that it is able to think in terms of programs, or think in terms of what, um, let's say algorithms. Yes. Hence the topic, what thinking programmatically. So in this particular session, we are going to look at concept of algorithm, pseudocode, flowcharts, and then instructions. Instructions, we've touched on that yesterday. So the main components of today's session is actually algorithm, pseudocode, and then flowcharts. Okay. So having said this, we are saying that these three components that we have highlighted, algorithm, pseudocode, and flowcharts, they are building blocks for problem solving. When it comes to problem solving in the computer world or in programming, these are the building blocks. So it is very very crucial that we understand what they mean and how they can help us. Algorithms, pseudocodes, and flowcharts, they help us develop what we call efficient. Hey, whose microphone is on right now? Yes, so they help us develop what we call efficient solutions. Whenever you have a problem and you try to solve it, you come up with what we call a solution. Yes, so these three concepts are very very paramount to your programming journey. All right, so that is that. Let's box on. So at the end of the session, you should be able to understand the concept of thinking programmatically and its significance in solving, in problem solving and programming. Define what algorithms are and recognize their characteristics, that is, input, output, determinism, finiteness, and then effectiveness. We also learn how to express algorithms using pseudocode, a high level description of what? Program logic. And then also we go ahead to explore the use of flowcharts as a visual representation of algorithms, understanding common symbols and their meanings, and all that. And if time permits us, we will try to put our knowledge into practice by creating a pseudocode and flowchart for different problem solving scenarios. And that is basically the objectives of this particular session. Now, let's take it step at a time. When we say algorithm, what is it? When we say algorithm, what is it? So I have a diagram here. When you analyze it carefully, you can tell that, okay, let me use my pen and pen laser pointer here and see. Yes. So I have this diagram here. It is having a block called input, another block called algorithm, and then another block called what? Output. Please, I hope you are following.
Yes, we are following.
Yes, sir.
Okay. So, when you try to understand this diagram here, the basic thing or the basic inference we can make is we have an input, and then there is some sort of algorithm who is trying to join, and let me add the person already. Someone wants to join. Okay, who is that? Admit all. Okay, so I think I can go full screen. Please, I can't see the diagram from my side. Whoa. Please, can you see the screen? Can you see the screen?
Yes. She has to enlarge. She has to enlarge it.
Oh, okay. So
So I think the screen you can use your finger to enlarge it for yourself.
oh, okay. So when you are using phone, just use your fingers to pinch. Sort of zoom in, and all that like that. So try it, and see. Let's see. Okay.
Those facing the program can also rotate their phone. If you rotate the phone
Yes. When
in a
you put it
landscape
in a
form, you see,
landscape format too, I think that one also help, right?
it will help. That one
Ye-
also help.
Okay. So you guys should try it and let's see. Okay. So like I was saying, oh, this and I thought I went into a full screen mode. How did I do it? Let me see full screen. All right, let's box on. So, like I said, there is an input block here, and there's what? An algorithm block, and there is an output block. So, an input is fed into the computer. There is some sort of algorithm that is in place to act upon the input to give us what? An output. So, we are going to say that algorithm is basically set of steps that are outlined to accomplish a task or solve a problem. They are basically what? Series of steps. Normally we say logical steps that are used to what? Solve a problem or accomplish a given task. That is basically what an algorithm is. So when you have a scenario where you ask someone to tell you how they are going to get the result for maybe adding two numbers, maybe 2 and then 2, how they are going to what? Come up with the answer to be 4. The steps that they are going to go through is basically an algorithm. So let's say you have what? 2 on the left side, you have the operand and then another 2, then you bring your equal sign and then you give what? The result. So all those things that I've just mentioned, all those steps that I've highlighted, it is some sort of what? Algorithm. It is some sort of algorithm. So the input is, okay, give me the result of what? 2 plus 2. So we now have to think and then be able to tell that, okay, when we want to do something like 2 plus 2, it is sort of what? Addition. And so therefore we need to come up with an addition approach and then add those two numbers to give us what? An output. Basically. So that is what an algorithm what is. They are just set of steps that helps us accomplish a particular task or solve problem. Okay, I have another definition here. Let's look at it. We are saying that an algorithm is a step-by-step procedure or set of rules for solving a problem or accomplishing a task. So here the takeaway is what? Step-by-step procedure that are laid down for solving a particular problem or accomplishing a task. I believe this is much self-explanatory and we can move forward. Now, it is important that having understand what an algorithm is, you get to also know some characteristics that comes with what? An algorithm. You need to know. And so therefore the next thing we are looking at is what? Characteristics of what? Algorithm. So when you have an algorithm, there should be an input what? Part. So you ask yourself, what data is needed to solve the problem? What data is needed to solve the problem? What input are we interested in from the user for we to act on with our algorithm to be able to come up with solution? So that is the input part. Now there is also an output part of what? An algorithm. What result is expected from the algorithm? We know that when you are able to write a basic computer program, that if users enter, let's say 4 and then plus 4, we are supposed to get 8 as the output. But then if we are not getting an output, the output part of what? Algorithm is missing. And then if we are not getting the expected output, let's say we had 16, that is what? An output, alright, but then it is not the correct what? Output. So always note that there is also what? An output part of what? Algorithm. When you are writing your algorithm, you need to have the input part, the output part. Now we also have another crucial part, which is what? The determinism. More or less like the control flow part. When I say the control flow part, it is which determines if the algorithm should continue executing or it should stop. So let's say here I said each step in the algorithm should be precisely defined and lead to a predictable what? Outcome. So we ask, okay, when we ask the user to enter maybe 2, we have to check if indeed the user has entered 2 or not. If the user has entered 2, now we are able to determine that the user has entered 2, and so therefore we can move to the next step. But then if we are not able to determine that, it can lead to some anomalies in our programs, And so therefore we should be able to determine situations in our algorithm, hence the determinism part of an algorithm. Now we also have what we call the finiteness of what? An algorithm. When we say something is finite, it means it has a stopping point. It has a stopping point. So when you write your algorithm, when you write your set of instructions to solve a particular problem, it should end. It should not be infinite. It should not be infinite. It should have a stopping point. So the algorithm should terminate after a finite number of what? Steps. So you go through step 1, step 2, step 3, step 4, and if it gets to the 10th step, so ideally we are saying that the 10th step should be what? Your last step, and then after that your algorithm should terminate. It should stop. So there is also the finiteness what aspect of an algorithm. If you are writing your algorithm and you don't have the finite aspect of it, then something is wrong with your algorithm. Okay. Now we also have one crucial part, the effectiveness of what? The algorithm. You could have so many ways of solving a particular problem, but you should be able to come up with the much effective way that can solve the problem and solve it much quicker. Yes. So when you gain grounds and you start writing algorithm to solve problems from basic problem sets to complex ones, be mindful of the effectiveness of your algorithm. So we say that the algorithm should be practical and feasible to execute. It shouldn't be something that is so cumbersome that even if your fellow programmer or whoever chance upon it, it will be very difficult to even make sense out of it. Like, your steps should be precise and concise, and that way the computer can also follow easily. So that is basically that. And these are the few characteristics of what? An algorithm. Any question up to this point? Are we good? Are we good?
Yes, sir.
Okay, I'm only hearing response from
Yes,
one
sir, we are
person.
good. We are good.
Okay,
We
okay,
are good.
okay. All right, so
Yes, sir, we are doing good.
okay, so those are what? The characteristics of algorithm. Take note of that. Take note of that. Let's move to look at another component that is also very crucial. We said that always established from the start of the session that we are going to look at algorithms, pseudocodes, and then flowchart. Now we've established the fact that these are the three building blocks of problem solving. When you want to think programmatically, when you want to be able to write instructions for the computer to really perform well, you need to understand these three components: algorithms, flowcharts, and then pseudocode. Now we've talked about algorithms, saying that these are just series of steps or step-by-step instructions that are laid down to solve a particular problem. We've established that. So we are now moving on to look at what we call pseudocode. 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 Let me see if I can use a pen here. Is it not working? Yeah, so we are looking at what? Pseudocode. Pseudocode. Now, when we say pseudocode, what does it mean? What does it mean? It is basically a high-level description of a computer program or an algorithm that uses natural language construct to represent program logic. I can tell that maybe what I'm saying is a bit abstract, so let's look at what I have here and then we can try to demystify it much clearer. So I'm saying that pseudocode is a high-level description of a computer program or algorithm that uses natural language or natural language construct to represent program logic. What does it mean? What does it mean? We are saying that when we say high level language, yesterday I did touch on that high level language is equivalent to human readable language. So when I say print hello, any person who is able to read and write English would be able to tell that, okay, print hello. Maybe you might not understand really what the print hello means, but you are able to read it and get a fair idea about it. So that way we say that is a high level what language. The computer does not understand that. And we are saying that pseudocode here is a high level description of a computer what program. So if you have what a simple program that is able to tell the age of what individuals, well, you are going to give, let's say, your date of birth to the program. You enter your date of birth and then it will tell you your age. It will tell you your age. Now the instructions or the algorithms that are underlying that program are what we call what how do you call it, a program logic. But that program logic can be represented in a high level what construct, where we say, okay, for the program to work, first of all accept user input. So let's say accept what, or allow user to enter their age. Now the next step would be like, after the user has entered their age, extract the year, and then extract what, the month, and then extract the day, and then work on that. Calculate it however you want to calculate it, and then come up with what, the real age of the person. So what I've just illustrated or highlighted, it is a high level description of a program logic, and that we term it to be what, a pseudocode. So more or less we say that pseudocode is an English-like statement. It is an English-like statement that is used to represent a program algorithm or a program logic. Let's look at example. I believe that can maybe solidify your understanding. So let's look at that. So pseudocode. So first of all, this is a basic program. We are saying that, okay, the program is just to tell that, okay, the number you entered is greater than, let's say, 10 or less than what, 10. So first of all, we are saying that enter what, enter value. Anybody at all can read this, right? Yes. And we are saying that if value is greater than 10, say what, say your number is greater than 10. If value is less than 10, say that your number is what, less than what, 10. And this is what, an English-like statement. This is an English-like what, statement. So a program logic that is written in such way, we term it as what, a pseudocode. A pseudocode.
Sorry, sir.
Okay,
Please, can you come again?
I should take it again, eh?
Yes, please.
All right.
Thank you.
So I was saying, let me try see if I can wipe the where is my eraser? Erase. Okay, good. And then pick a pen again. So we said that talking about pseudocode, it is basically a high level description of a program logic. So when we say program logic, these are just the series of instructions that are lying behind a particular program to behave the way it is behaving. That is the program logic. But then the program logic that is powering the program is understood by the computer in binaries, zeros and ones. But for we humans or programmers, sometimes we might want to really write down our instructions before we go ahead and write the program according to those instructions. So we are saying that there are so many ways we can do that. One, we've said algorithm is what? One. These are series of steps that we follow to be able to come up with a solution for a given problem. Now we are saying that the solutions that we come up for a given problem can be represented in one way we call pseudocode. In one way we call what? Pseudocode. And pseudocode is basically what? An English-like statement that describes what? The step-by-step procedure that a program follows to be able to what? Solve a particular problem. So here, the problem can be that, okay, write a computer program that is able to tell a user that the number or the value they entered is greater than 10 or less than 10. That is the problem set. That is what? The problem set. So how can we represent the solution using pseudocode? How can we represent what? The solution for the given problem using pseudocode. Now, according to pseudocode, you have to use English words or English-like statement. Sometimes you can include a bit of what? Technicality, but more often it is advisable to stay plain. So when you look at this is step 1. This is step 2. This is what? 3. This is 4. And then what? This is 5. Somewhere, bear with me with my 5 and 4. They look weird anyway. So these are what? Series of steps. But these steps are written in what? English-like statement, and it's easy to understand. And this sort of what? Step-by-step instruction will tell me to be what? Pseudocode. Period. Do you understand?
Yes.
Yes,
please.
Understand?
Hello, come again. Do you understand?
Yes.
All right.
Yes, please.
Yes, sir, too.
Okay. So let's proceed. That is pseudocode. Let's look at another example. Now, it is very crucial that you know how to write pseudocode. So I have this diagram here. One I've indicated. This is a good word, pseudocode, and then this is what? A bad pseudocode. So looking at the good pseudocode, you see that all these things here are English words. So for each index of what? String, if string index is equal to hash, then return hash found, and if and for. So this is more or less like a program that has been written already, but when you are really serious about what you are doing, you should be able to read this thing and understand. As a technical person, you should be able to read this and understand. But when you look at the other side, it said for I equals 0 to 20, if string at index I is equal to hash, return hash found, and if and for. And there's another part for each word. Index of string, if string is blah blah blah, like up to this point. When you are doing this, you are moving away from the rules of what? Pseudocode. You see that there are a bit of technicalities in here. So something like what? This square bracket notation. This is what? Used to grab an index of a particular given what? Input. So if you don't really understand this, and then you are trying to use pseudocode to understand this concept, you are going to find it very difficult. So this sort of approach here, we are saying what? It is a bad pseudocode approach. It is a bad pseudocode approach. But this one here is good. This one here is what? Good. Everything is what? In English-like statement. There is no much technicality. Okay. Now there are advantages of what? Using pseudocode. Let's look at some of them. It provides what? A structured and readable format for expressing algorithms. Structured and what? Readable. The keyword is structured, and then what? Readable format. It also allows programmers to focus on the logic of the solution without getting bogged down with syntax. So when you are having a pseudocode to a given problem, what happens is it allows you to focus on the logics. Oh, okay, you get to understand, okay, from here I need to move to this part, I need to move to this part, I need to get this done, and I need to get that done. So you wouldn't have to be really concerned about syntax and all that. Syntax is another keyword that we are going to talk about later in our discussion, but for now, syntax is basically what? How you are supposed to write down or do a particular thing when it comes to what? Programming. It is not only programming, but it also works in other what? Field or discipline. So when you are speaking English, we say that there is a syntax, there is a grammar syntax. We call it, is it grammar rules or what have you? We have those.
Syntax error.
Syntax error, eh? Yes. So when you are not able to follow the grammar rules, we said that you are going to commit what? Grammar errors. So when you are saying that, okay, Kofi is calm. Kofi is calm is a bit of what? Error. So you probably wanted to say Kofi is coming and you are saying Kofi is calm. That is syntax error. The grammar rule will tell you that there is some sort of error in there. So syntax is basically how you are supposed to what? Write down or say a particular thing. So that is that. So we are saying that it provides what? A structured readable format for expressing algorithms, and also allow programmers to focus on the logic of the solution without having to be bothered about the syntax needed to be what? Used. So these are few advantages. You can read more on this, make research and read more on this if you want to really widen your knowledge base. So we've also what? Tackled pseudocodes. I believe we've grabbed or made some sense, and we can move on to look at the next component of our discussion today. That is what? Flowchart. Flowchart. Now, what are they? Flow chart. Flow and then what? Chart. Two words that have been combined. Flow and then chart. Something flows. It moves in a particular what? Dimension like that. And then we also have what? Chart. When you hear of flow chart, it is basically talking about diagrams. So if you can't keep the definition for flow chart, just know that whenever you hear of flowchart, it is basically going to talk about or talking about diagrams. Okay. Now, a flowchart is a visual representation of the sequence of steps and decision points in an algorithm or process. So, let's try to understand this very well. We are saying that flowchart is a visual representation of what? The sequence of steps and decision points in an algorithm or process. We've established the fact that you can use pseudocode to outline the steps that are involved in solving a particular problem. But then these steps that you outline should be in an English-like statement. And also we are also building on that knowledge, saying that flowchart is also another approach of representing the steps to help us solve a particular problem. But then this time around, we use visual elements, basically what? Diagrams or shapes to represent what? The steps in solving a particular problem. Okay. With that said, there has been some standardized symbols that we need to introduce ourselves to be okay when using flowchart. Please, someone's microphone is on. Kindly mute yourself.
Agodo, please switch off your microphone, we beg.
Yes. So there are some standardized symbols that are implemented whenever you think of using flowchart. So when you have a problem set, when you are given a problem set and you want to come up with solution for that problem set, you can think of using maybe a pseudocode or a flowchart to come up with an algorithm. But then when you think about flowchart, when you want to use flowchart, there are some symbols you need to use, because we said that flowchart is basically the visual representation. It means you have to represent your solution in, using what? Visuals, shapes, diagrams. And so let's look at some of these symbols that are there for us to use. So we have what? These ones. Where is my pen? Okay, it's here. We have what? The symbols are here, and then their uses or their purposes are also what? Beside them, like that. So this is what? Let me ask, this first shape here, the first shape here, is it circle or not a circle?
It's an oval, sir.
It's an oval shape, eh? Okay, it looks
Oval
like
shape.
some people would say it's what? Circle, but please, it's not what? A circle. Note that it is not what? A circle.
Sphere.
It is an oval shape. It is an oval shape. Thank you. So where is my pen? Okay, in color, and then R option. It's as though my pen is very, very thin. I don't know why, but let's manage it. So this is what? An oval shape. This is an oval shape. What is the essence of the oval shape? What is the essence? What is the essence? It is used to denote the starting and the ending point of an algorithm. It is used to indicate the starting and then the ending point of an algorithm. So when you have a step-by-step instructions that the computer needs to follow to solve a particular problem, we are saying that when you want to represent those step-by-step instructions using flowcharts, you would have to have a starting point and then an ending point. So if you want to start, you would have to use this oval shape. You have to use an oval shape to tell that, okay, this is the starting point of the algorithm or the solution. And then when you are done with the algorithm, you need to still implement this oval shape to indicate the ending point of what? The algorithm. So that is that. Now this looks like a rectangle, but it is tilted some way somehow. I cannot say this is a parallelogram or whatever. I can't say that, but it is sort of a rectangle shape that has been tilted a bit. So note that. Now what is the essence? It allows or helps to represent input and output within an algorithm or within a flowchart. We use this symbol to represent what? Input or output. We also have the rectangle shape itself. This one, you see that it is not tilted, it is just as it is, the rectangle we know. And now we are saying that this rectangle here represents what we call process. It is used to represent what? A process or processing. Process or processing. We also have another one. We can say this is a kite. A kite. We can say this is a kite. When you look at it, you can say it is a square, alright, because all the sides are equal. But then it is tilted some way somehow. Can we say it's a diamond shape? Can we say this shape here is a diamond shape?
No, it is not a diamond shape.
No, please, it's not.
It's not. Okay, so let's say it is what? A kite, basically. Let's just say it's
So
a
a
kite.
kite.
Yes. So let's just say it's a kite for now. Alright. So we are saying that it is used to what? Make decisions. Oh, okay. So if the user, we are saying that the number that the user is going to input, let's say we have a program that allows what? Users to input numbers. But we want the numbers that are going to be given to the system should have a particular range. Let's say it is starting from 1 and then ending at 20. So we have to make decisions remember that when you look at the part of an algorithm, we mentioned one to be what? Determinism. Where I said that you should be able to determine situations within your program or algorithm in order to what? Make decisions. So this symbol here helps us to what? Make decisions. So if in case someone enters what? Enters maybe 21, which is out of our condition, because we said that it should have a range from 1 to 20. So if someone should enter 21, the person is going out of range. So here we have to make decision and perhaps re-prompt the person to enter what? A number that is less than what? 21. And so in that case, we use what? This symbol here to make decision. We are going to see a practical, let's say a diagram that is indicating how this shape is what? Implemented. All right. Now we also have the flow line. Flow line is basically what? It determines the flow of what? Instructions in the computer program or the algorithm you have what? Stated. It tells, okay, from here, the program needs to move towards the next part. So let's say from here, from the starting point, you move to what? The input or output part, you move to the processing, like that. So sort of what? Kind of this thing. So okay, maybe from here it's what? Moving downwards. Okay, from here it needs to go back to what? The top. So you do something like so, which is indicating what? The top part. So we use what? These flow lines. We use these flow lines to be able to what? Tell, okay, how instructions are communicated in the algorithm. We also have what? The annotation. What is it used for? What is it used for? Now, the annotation is basically used to what? Connect two or more, how do you call it? Symbols. It is used to what? Connect two or more symbols here. Hey, who is trying to join? Maybe someone wanted to join. Let me view it. Admit all. Who is coming again? Someone wants to join. Why is this thing not automatic? Because I can't be coming back to be adding people.
There's a settings for that
There's
before
a
you
setting
start
for that
the class.
before you start the class.
Yes, please.
Oh, okay. Then I'll check that later. I've not really implemented that before, so I would check on that because I can't be coming back adding people. Okay, so let's continue. Let me go to full screen mode. Full screen. Come back here. Okay, so like I was saying, this annotation is used to what? Connect two or more part of what? These particular symbols. Basically, don't worry so much about them. We are going to see a practical example. Right. Alright, so sorry about that. Let's continue. We also have the connectors. Let's get to see a practical example and then we can make meaning out of it, like there. So look at this diagram here. Look at this diagram. we have, let's try to make meaning out of these ones. Let me bring up my pen. Now look at this first part here, the first box. Let's look at the first box. What can we say it is? When you look at the instructions, what can we say it is? The three components we've mentioned, where can we categorize this particular instruction?
Please say it is pseudo.
Pseudocode, right? Good.
Yes.
Good, and I believe
Yes,
most of
please.
you are siding with him. Yes, it falls under what? Pseudocode, because this is an English-like statement. This is an English-like statement. Alright, so look at the flowchart part. We are saying that move forward 100 pixels, then 10 clockwise 90 degrees. Do this a total of what? 4 times. Someone is wanting to join again, I believe. Let me see if I can set turn on captions, and then is it joining settings? Video general. Reaction. Okay, so let's continue. So this is what a pseudocode. Now let's look at how this pseudocode is represented using what? The flowchart. So we said that the oval shape is used to indicate the starting point of what? The algorithm, right? And you can see that here. So first of all, you draw the oval shape, and then you just write what? The instruction on the start. Or you can say maybe yes, normally we use the word start, and then when you terminate or you end the program or the algorithm, you write on it what? Stop. So it said move. Okay, this is what? This is not for this, so I think it's this one instead. So yes, when you start, this shape here indicates what? What does it indicate? The second shape, this one.
It's input and output.
Good.
Or output.
Exactly. So here there is an input what? Coming in. So is that pen down? Pen down. And then there is also what? The processing part. Is it processing?
Sure, it is.
Yes. Yeah, so is that what? Pen down and then what? Count. So count is equal to what? 0. Then it is saying that okay, the next step, another input. So move forward 100. Move forward 100. If it moves forward 100, then the next input is what? 10 clockwise 90. So move forward 100, then 10 clockwise what? 90. Input. Now, if it is able to do these two things, you increment what? The count. You process the count that you've defined here to move from 0 to 1. It means the person has done this what? For the first time, because when you look at the last part of the pseudocode here, it is saying that the person should do it how many times? 4 times. Someone wants to join again. This thing. Admit. So amongst the total number of people in the group, only 18 people have been able to join. Okay, let's see how it goes. Okay. Yes, so you could see that according to the instruction, these two steps should be what? Repeated 4 times. So we say, okay, we need to have a way of tracking if the first step is taken. So here we define a variable, or yes, so this is basically a variable. Some of the terms, when I'm using them, you might not be familiar with them, but then we are going to look at them as and when we progress. So that is that. So this count here is a variable that is going to store a count. So if these two processes take place, or let's say inputs take place, then you process this count to move from what? 0 to 1. So count is equal to count plus 1. So this time around, we now have counts to be holding the value of what? 1. Now, this comes down and then move to what? The next step. I told you there is one shape that is used to make decisions. What is that? This kite shape, right?
Yes, please, the kite shape.
Good. Oh, but how come it keeps disconnecting? Or he is now joining? Okay. Yeah, so the kite shape is used to make decisions. So here there's a decision going on. You see the flow lines, these arrows that are coming, these are flow lines, and even the arrow that is moving from here to here is also another flow line. We've touched on that already. So this kite shape that is used to make what? The decision. We are saying that, where is my pen? My pen. This kite shape here is making decisions. So check. It said count is equal to 4 and then question mark. It means that basically check if the count, the value that is held in the count here is 4. If it is 4, it means the program has to what? Terminate. So this Y here means what? Yes. If this place the decision is made and it's true, is yes, it means you have to come here and then stop what? The program, because according to what? The pseudocode we have here, you have to do it how many times? 4 times. But then if you
Four
count,
times.
yes, but then if you count and it's not up to 4, then you reverse. That is what? No. You reverse and then come and do these 2 steps again. You move forward 100 and then you turn clockwise 90 degrees. Then you come back, you increment it. This time it becomes what? 2. Then it checks again. Is it up to 4? No. It comes to this block, it falls here, it goes back, it repeats until it gets to 4, which makes the decision block here to be false, and then the program will now move to what? The stopping part or the termination part. That is basically that. Flowchart. Any question?
There's a lot of questions.
Uh-huh.
Say honestly.
Okay, let me hear you. Let me receive your question, because this is the last thing we are supposed to talk about this evening, and then in our next session we are going to. Okay, let me not talk about that. When we are done with the question and answers, I'll touch on those. So let's come up with our questions. Yes.
Hello.
Yes.
Yeah, please, I don't understand the flow chart. Can you highlight it again?
You don't really understand it. Okay. Any other question?
Yes.
No, I think the flow chart is well understood, but
Yes, but what? Oh,
the
But
symbols, understanding of
represent
the, I mean, the meaning of the symbol.
the meaning of the symbols is what is the issue, eh?
Yeah, the meaning of the symbols.
Yeah. So you have to take
But
time.
with the input and the processing, I get that.
You get that? Okay. Okay.
Yes.
Um,
Okay.
Fairness,
Yes.
please.
Uh huh.
Fairness.
Yes, I'm listening to you, actually.
Hello.
Yes, I'm listening.
Okay, so my concern is if I understand this very well, you can only make use of a flow chart when you have a pseudo code in place, right?
Not exactly. Not exactly.
Hello.
Yes. Do you have a follow-up question, or I should address what you've asked? Do you have a follow-up question, or I should address what you've asked? Okay. So let me see if
If you can
okay, let me address it. Hey, my brother, please.
clarify for me, because per the presenter assumed that you need a pseudo code in place, then you use that to put up a flow chart. That's if you want to use flow chart to represent a step by step
Okay.
solution.
Okay.
But you said it's not exactly that. So
Okay,
if
so let
you
me just
can
touch on that.
please explain.
Now what happens is, if you are ahead and then implement it with a given problem set, you can just go ahead and use the shapes to represent what your algorithm or your solution. But then if you are not really okay with flowchart, or you want to make your life easy, okay, you want to make your life easy, what you can probably do is you have your step-by-step instruction or solution in a pseudocode format. Then you can base on that to translate into what a flowchart. Mind you, all these ones are ways of writing solutions to a given what problem. So I can pick this pseudocode here and then use it to what write an instruction for the computer to what follow. I can also pick the flowchart and then follow it to write an instruction for what the computer to follow. But then it all boils down to your preference. If you want to use flowchart, use it. If you want to use pseudocode, use it. If you want to use both, use it. Have I made some sense? Hey, my Mac isn't working. How? Can you hear me now?
Please,
Yes,
yes.
please.
Okay. Okay. So Wajoli, you asked a question. Are you okay now?
I think her
Well,
network is
I
disturbing.
didn't
She's
hear
back.
any response you gave.
You
I
didn't hear
don't know
any.
if it's from my
You didn't
end,
hear
so I had
anything.
to exit and join the meeting again.
All right. So okay.
I also didn't hear.
No, after my question, it just went dead from the other side.
Okay. Let me retouch. Re-highlight what I said. So I said that whenever you're having a problem set, whenever you have a problem set, you can decide to use pseudocode to represent a step-by-step solution, or yes, to the given problem set. You can also decide to use a flowchart to represent the step-by-step instructions to follow to be able to solve the problem. You can use both. If you feel like you want to use pseudocode to have the English-like statement, then you can pick that to represent it in a flowchart too. You can also do that. But then it all boils down to your preference. It all boils down to your preference. But then for me, if you give me this pseudocode, for instance, when you give me this pseudocode, for instance, I can use it to write a computer program because I can make meaning out of it. Okay, you said move forward 100 pixels. then 10 clockwise 90 degrees, and then do this what, a total of 4 times. I can use this to write a computer program. But then if you feel like you want to make it more concrete, using visuals, using diagrams, using shapes, then you can also leverage what, the flowcharts. You can also leverage the flowchart. So there is no limit as to what you use and what not to use. It all boils down to your preference. Have I made sense?
Yes, please.
Okay.
Yes, please.
All right. Good. Now, someone also said that he didn't really get the flowchart well, so let me reiterate it, and I believe this time around you should be able to grab it. So pay rapt attention whilst I retake it. Okay. So
Yes, sir.
I'm saying that flowchart is just another way that we can represent a solution for a given problem. Now, one thing that I tell people, or when I'm trying to let you understand a concept, I am very particular about certain things. You don't just use words, you don't just listen to whatever you are being fed. You try to make meaning out of whatever you are receiving. That way it gives you a different perspective of whatever that is going on, and that way it opens another door for what, questions and answers. So I'm saying that flowchart is just another way of representing what we call solution to a given problem set. So you need to understand what a solution is, what a problem set is. So a problem set is normally the problem that you have, the task that you are supposed to perform. So it is that, okay, write a computer program that is able to calculate the age of individuals given their date of birth. Write a computer program that is able to calculate the age of what, individuals using their what, their date of birth. That is the problem set. Now, when you want to come up with what, the solution, when you want to come up with a mechanism to how do you call it, solve that, we said that you are trying to come up with what, solution. So that solution, you can use what we call a pseudocode to represent the solution, or you can use a flowchart to represent it. So we said flowchart is the visual representation of the step-by-step instructions to solve a given problem. Visual, when I say visual, it boils down to what, diagrams, the use of shapes. Unlike the pseudocode where we were using what, text, words, but here we are using shapes to what, to communicate the solution to the given problem. But then what you have to note is that if we are using shapes or visuals to represent the solution, we don't just stand up and use any shape at all. There has been standardized shapes and visual elements that we use to represent solutions using what, flowchart. And these are the ones we've what, highlighted. So if I go back few slides, I said we have what, some of these symbols. You can check online and see if we have a couple of them, but these are what, the most common ones. You have what we call the starting point. Like I said, when you go back and look at the characteristics of algorithms, there is the input part, there is output part, there is the finiteness part of it. More or less like the finite part of it. You would have to have a starting point, you have to have what, an ending point. And you have to have what we call the determinants. So the determinants, all these things, when you're able to understand the characteristics of algorithm and then you understand these symbols, you see that, okay, it makes sense that, oh, okay, they are really aligning. So we are saying that when you have an algorithm, it should be finite. It means there should be a starting point and an ending point. So we are saying that if you want to use flowchart to represent solutions for a given problem set, you should have a starting point. And the starting point is that, according to the standardization, use an oval shape like so, this one here, to represent the starting point of what, your program. And then there is also an input part and an output part. The output is normally display, you can say display or storage. So you either have the thing displayed on the monitor for you, or let's say it is printed out, or it is stored on another medium. That is output. But input could be the user what entering some data through the keyboard, or using a computer mouse, or using the microphone, or what have you. Those are input. And you are saying that for you to represent input using flowchart, you have to use this symbol here. It looks like a rectangle, but it is tilted a bit diagonal. That is that. Now, there is also the processing part of what? A flowchart. When you have an algorithm, there is a processing part. So the processing part is basically, okay, you need to process something in order to make what? Decisions. So you process, and then based on the process, you're able to make decision out of process and all that. So we are saying that for you to represent what a process is, you have to use the rectangle shape here. Use it to represent what? A process. We also have what we call the decision. Decision. Every day we make decision. Every day we make decision. Even for you to join this online session, it was a decision that you made. You can decide not to join. You can also decide to join. It is a decision you have made. So in programs, in computer programs, in algorithms that we write, we make decisions. We make decision. And in order to make decision, using flowcharts, we use this symbol here. It looks like a kite, so you can say kite symbol. You use this symbol here. You see that it has what? These four corners. It has this what? Four corners. It means that, okay, something can pass this direction, something can pass this direction, something can pass this direction, and another decision can also what? Be made through this path. Decision box. We have the flow line. This flow line is basically what? The lines that are connecting the shapes together. So basically, it is very important that you understand these symbols, and that way you are able to come up with what? A flowchart that is meaningful. If you are not able to understand these symbols, that is when you are going to fumble. So I would urge you that you take your time to visit the symbols and know their uses and their functions like that. Alright. So we started off to look at the practical implementation or examples of what? These symbols. So we used what? This example here. So this is what we established that, okay, this instruction we have here is actually what? A pseudocode. And this pseudocode is already making what? Sense. Some programmers can base on this pseudocode to write a computer program that will work perfectly. Some too can what? Decide to translate this to what? A flowchart. So you could see that this flowchart is using what? Shapes and symbols. Shapes or symbols to be able to what? Represent the step-by-step instructions, or the step-by-step what? Instructions you have to follow to be able to solve this particular what? Problem. And already the shapes that we've highlighted, the meaning of the shapes, or the shapes that we've highlighted and their functions, some of them are implemented here. So this is an oval shape. We said that you need to have a starting point. So this is what? Always the starting point. Then this is what? An input. And this arrow you are seeing here, that is a flow line. That is a flow line. It is connecting this what? These shapes. Who wants to join? The person has declined. Okay. Yes. So you need to really understand what? The shapes. That way you are able to what? Implement. It is very easy. It is not difficult. It is not difficult. It is not difficult. So what I'll do is to test your understanding of what? The flow chart. After the session, I'm going to craft a nice problem set and then ask you to represent it using pseudocode and then flowchart, so that I would be able to tell, okay, if my students are really making headway or not. The most important thing is for you to what? Understand how to use the symbols. How to use the symbols. But normally this is how it flows. This is how the structure is. It can look a bit, it can look more complex than this. If you have much more complex problem set, you would have a complex flow chart. So when you Google online, you are going to see simple ones and complex ones. So depending on your problem set will determine how complex your flow chart is. When you look at this instruction here, move 100 pixels, move forward 100 pixels, then 10 clockwise 90 degrees, and then make sure you do this 4 times. These are simple instructions. So when you look at the flow chart, it is very simple. It is very simple. Here, it's very simple. So what happens is, okay, we start a program. Now you receive an input. You pen down. Pen down means, okay, try to have a starting point and then take note of where you are starting. Now, when you are starting, make sure you have a counter that will keep track of how many times you are doing the thing. Okay, we are saying that this is an input that is received. So we have to what? Use the input symbol. This represents what? The input symbol to what? Represent this part. Now when you're able to pen down, you need to keep track of what? A counting variable, a counting mechanism. Okay, when races are 100 meters, 200 meters, those sporting activities have been held, how are you able to know that, okay, the person has gone maybe 1 round, or go 2 rounds, 3 rounds, and all that? How are you able to know? When a person starts, there is a starting point. So you take note of the starting point. When a person goes and then gets to the starting point again, it means the person has gone 1 round. And then if the person goes and come back to the starting point again, that is what? The next round, which is the second round. So in our program, because it is saying that we are supposed to do this thing with a total of what? We should do it 4 times. We need to have a way of tracking if we are really doing the thing. So when we start from 1, we move to 2, we move to 3, and then we get to 4. We need to have a way of what? Tracking it. That is how come we are having this part here count. So this is a process. Okay, start from 1. When this process happen, when we receive the input and then it is processed, make sure you process this count again to another state where we make sure, okay, we started from 0, we are now at 1, we are now at 2, we are now at 3, and then we get to what? 4. Now listen very carefully. Flowchart, it is easy to understand. It is very simple if you pay much attention to it. More importantly, understand the symbols. If you think that you are trying your best and you are not really getting it, you can stick with pseudocode. It will still do the magic for you. If you get someone who can translate your pseudocode to flowchart for you too, that is fine. But trust you me, if you give a little attention to the flowchart, it is easy to understand. Using of symbols to represent what? Your step-by-step instruction. Using symbols to represent your step-by-step instruction. And you don't just stand up and use the symbol. You need to use the symbols according to the instructions you want it to happen. Alright, so I think I've made some input and some understanding have gone down. So I would stop talking and then invite you on board to bring up whatever you have, and then we look at the way forward. Are we there?
Yes, sir.
Yes. So like I said, if you are not really getting the flowchart, you can use the pseudocode approach. Just write your English. Okay, step 1, move forward 100 pixels. Step 2, 10 90 degrees clockwise. And then step 3, repeat the step. I mean, these two steps, repeat them what? How many times? 4 times. You can decide to put your instructions in that manner. If you really understand the flowchart and you want to use the flowchart too, you can use it. If you want to use both too, that is also what? Fine. The most important thing is that if you decide to go with a flowchart, understand the symbols. When you understand the symbols, it is easy to what? Implement. Period. Any question?
I think now it has gone down very well.
Okay. That is okay. That is good. That is
The
good.
flow chart, the flow chart is very easy and very
Yes.
good to use for
Yes. When
representation.
yes, when you really understand it, it's very very easy. Yes. Any other? Any other? Any other?
Okay, sir.
Uh-huh.
Please, so with the flow chart, are you to bring the yes and then the no symbols?
Yes. So whenever you have a decision, so you know this symbol here that represents a kite, like we say, we are saying that that looks like a kite. It's a decision box.
It's a
So
decision box, yeah.
good. So we use it to make decision. So anytime you are thinking about decision or you are making decision in a program, you need to have the yes and no. So this N is used to represent no, and then Y is what? Yes. You can decide not to bring the letter notation, but I think when it is there, it makes more sense for anyone who sees it. So
Okay.
basically here it is saying that okay, decide on the count. If decide on the what? The count. If the count is equal to 4, then it means that we cannot repeat the steps. We cannot repeat all these steps again, simply because we are asked to do it only 4 times. But then if it checks and it is false, it is no, it means it is going to take this part again, and then it come back and then repeat these 2 steps until it gets to 4. And then when it checks and then the count, uh, however we are tracking the counting, we check and then it is up to 4, then we say okay, the count is what? The count is 4, and then we can what? Move and then stop the program. Hello. Yeah, Mr. Mr. Internet. It's me online meeting you. Yeah, so I believe you understand it now.
Yes, please.
Okay. All right. So, any other question? If there are no questions, I believe that we've touched on so much. Please, all these things are important. Uh, to your surprise, it can happen that whoever is going to take you next semester for introduction to computer programming would not have the luxury of time to take you through all these things. So please take it serious. It will help you in your thinking ability when it comes to programming. If you have the opportunity for the person to take you through again, it will be an additional knowledge. But if you don't have the opportunity or the chance to, if you don't have the chance to what, get a person to take you through all these things again, then I think this would serve as, I mean, so much benefit for you like that. So please take it serious. Take it serious. Take it serious. Yes. If there are no questions, I believe we can end here. I believe we can end here. So let me hear from you. Are there questions?
My hand is up, please.
Okay. Yes. Let me listen to you.
Okay, yes, sir. Thank you, sir. Ernest.
Okay.
Based on these explanations, the flow charts, I think everything has gone down well.
Okay.
But my problem here is I'm trying to relate this to a practical aspect of something that we have been using daily.
Okay.
Let's say entering of password.
Okay.
You see, there are some websites you want to log in, you'll be requested
Don't
or you'll be
worry.
required to enter
D-
your password twice.
don't worry. Based on the question you are asking, okay,
Yeah.
I'm going to craft a question, and then it will be a problem set for you to use that problem set to come up with a solution. By the solution, you're going to use both pseudocode and then flowchart. It will basically be like, okay, you have a phone. How do you get to remove or unlock the pin or the pattern on it? So I would give you that problem set, and then you use those. I mean, that problem set, you represent the solution using pseudocode and flowchart. I believe when you're able to do that, it will give you much more sense or understanding to why flowchart and the importance of it. So don't worry.
Okay.
Yes.
Okay.
In our everyday
Okay.
life, we are using flowchart, we are using pseudocode, but just that we don't know. Like I said, even for you to join what? To join this online session is a decision. And that decision that you made can be represented in a flowchart. Okay, the decision is that um I would have to start. Okay, there's a starting point. I will take note of what the time. If the time is not what? It's not up to 8, I wouldn't have to bother about joining any online session. But if the time is 8, I'll check if there is what? A link posted. And if the link is posted, I'll click on it and then join. If the instructor or the facilitator is around, I would comport myself and then participate. I can represent that in what? A flowchart. Can you see that?
Yes, sir.
Can you follow what I'm trying to communicate?
Yeah.
Please, yes.
Yeah, so
Yes.
all the things we do, our life is what? Our life is actually programmed, but we don't really pay attention to how things are working. So when we try to uh, organize the information, it becomes a bit difficult. So don't think too much. Just like you asked, how can you relate it to a practical world? Just pick a simple thing that you've been doing regularly and try to think of it, or think of it in terms of what? Program, or think of it programmatically. When you are thirsty, what do? You drink water. But how do you drink the water? It's either you buy pure water, you buy the bottled water, or you fetch water in cup to what? To drink. You can illustrate those steps in what? A pseudocode or using flowchart. Do you get it? Yes,
Yes, please.
exactly. Any more question?
No, please.
Okay. As we've
Okay.
spent
No,
almost.
sir.
You have a question?
No, please.
Okay. Okay. So in our next meeting, we are starting to look at the actual deal, which is what? We are going to get our hands dirty with codes. We are going to start to do something. We are going to start to do something. So we are going to look at some programming terminologies. We are going to look at things like, we've touched on some of them already. Algorithm is one. We have flowchart. We've touched on. We have pseudocode, but we have other programming terminologies that we need to what? Look at. We have things like loops. We have variables. We have functions. We have what? There are a lot of them. We have source code, we have editor, we have debugging, we have bugs. So many programming terminologies. But then I wouldn't want to bore you so much with theory. So we are going to get practical in our next session. Or yes, the next session probably it will be a post discussion of maybe a tutorial that I'm going to record, because that is what you guys said I should do. So I'm going to record a tutorial and then share the link with you, and then perhaps when we meet the next time using Google Meet or what have you, we deliberate on whatever resource that I'm going to feed you or give you. So that is going to be our next line of what action. We are going to get practical. So please, I'll be posting certain things that you are supposed to have on your computers. Please, 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 lest I forget. If you don't have personal computer and you don't have the ability to get one right now, please try to make it part of your plan to get a personal computer. It will help you. Try to make plans. If you are going to be saving money towards that, I believe by the time you get to level 200 or 300, even 300 is too much, maybe 200 second semester, that is when you are not really financially capable. Oh. By level 200 second semester, you should get your own personal laptop. But then, if you have it, to please take good care of it and make proper use of it. But then, for you those who don't have computers yet, you can leverage your mobile phones. So I'll be highlighting some few softwares or applications that you need to get installed to help us in our in our programming journey. So please pay attention. And some of you too, when we post instruction on the platform, you see it but you don't respond. It's only few people who get interactive. And what I do is I kind of take that as what the general representation. I represent that as the opinion of all of you. So please, if you want something to be done for you in a particular way, please be interactive in the group. Be interactive in the group. Bring up your opinion, and then we can all make decisions and do things that will help every one of us. Yeah. So those are the few things I have to say. If someone has something to say, to fine. If there are no any further deliberations, I think we can call it a day. Whilst I've recorded a session, so I'll be hosting it. I'll be posting it on the channel, and then I'll share the link with you.
Okay, thank you.
Sure. So that is that.
All right, thank you very much.
Okay.
So, say Ernest,
Yeah.
I have one thing to say.
say Ernest.
Okay.
Please, what I have to say is that some of these things are very
Some of you,
technical.
your microphones are on. Please come
Even though
again.
we have watched it, even though
Yes.
we have watched
Say
it
Ernest.
now, when the link is being posted, at least we should watch it 2 or 3 times. Then we'll get to the full understanding of it.
Please come again. Come
That's
again.
what
I
I
didn't
want to
hear
say.
you. There was so much noise. I didn't hear you. Come
What I,
again.
what I want to say is that some of these things are very technical. So watching it now, it doesn't end here. At least when the link is being posted, we should watch it 2 or 3 times.
Okay.
With that, we'll get to the full concept of it.
Okay. Okay. Thank you. Thank you.
Say
Uh.
Ernest, please. When
Uh-huh.
is our next meeting?
When do you want us to meet?
I think the same time tomorrow.
At the same time tomorrow. I
That
think.
is 8.
Okay, that is
Or you
fine.
check your schedule, then give us the time. Then we discuss it in the WhatsApp group.
Okay, I will do that.
So you are leading us. You have to check your schedule, then you give us the day
Okay,
and the
I will
time.
do that. Okay.
Okay.
Please, let me say one thing before we close curtains on today's session. Please mute your microphone. I'm getting feedback. Yeah. So programming is difficult, and programming is also not difficult. It is difficult when you put up lackadaisical behavior towards it. And it is also simple or not difficult when you put up seriousness towards it. What do I mean? Nobody is going to chase you, nobody is going to force you to learn. Please, you should know what you are about. So even if it is 30 minutes of your time within a day, dedicate it to learn something about what programming. That is, if you are interested. In as much as we are saying there are so many opportunities, career opportunities and all that, it is coupled, for you to really get far with this thing, it is coupled with what? Interest. So please make sure you have the interest. If you don't have the interest, to try to understand, because you are going to write exams on it and all that. You need to pass your exams and pass well. So please get yourself serious because nobody's going to push you. You have to push yourself. Push yourself. When you don't understand anything, some of us, you are available, we will assist you. Those are the few things I want to add. Thank you.
Thank you for the advice.
All right. So we can call it a day. Call it a day.
All right. Thank you, Sir Ernest.
Sure, sure. You're welcome. Bye. Bye.
Thank you.
Thank you.
Bye.
Okay.
Have a
See
good
you.
evening. Huh?
Have a good evening, huh?
Okay.
Thank you.
Thank you.
Good
Good
night to
night to
everyone.
everyone.
All right. Good night. Good night.
All right, good night. Good night.
Bye. Yeah, give me. Bye.